What is yield strength and why is it measured for materials? Imagine pulling on a rubber band or a metal wire. At first, they stretch easily and bounce back. But if you pull too hard, they might stay stretched or even break. That point where they stop bouncing back and start to change shape permanently is what we call the yield strength. It's a key property that tells us how much stress a material can handle before it begins to deform in a way that won't reverse. In simple terms, yield strength marks the boundary between elastic and plastic deformation. Elastic deformation is temporary. Once you remove the load, the material goes back to its original shape. Plastic deformation, on the other hand, is permanent. The material stays bent or stretched even after the load is gone. Knowing this limit helps engineers decide if a material can handle the forces it will face in real-world use. For example, in building bridges or making car parts, you want to pick materials that won't bend or break under normal loads. To measure yield strength, scientists usually perform a tensile test. They take a sample of the material, often a small metal rod or strip, and slowly pull on it while measuring the stress and strain. The stress is the force applied divided by the cross-sectional area, and strain is how much the material stretches compared to its original length. The test produces a stress-strain curve, which shows how the material responds as it's pulled. The point where the curve shifts from elastic to plastic deformation is the yield point. If the material doesn't have a clear yield point, engineers use a standard method called the offset method, usually at a strain of 0.2%, to define the yield strength. Understanding yield strength is important because it helps prevent unexpected failures. If a component is loaded beyond its yield strength, it can deform permanently or even break. For example, metal beams in a building should have a yield strength high enough to support the weight and forces they encounter daily. If the load exceeds that, the structure could bend or collapse. Similarly, in machinery, knowing the yield strength ensures parts don't deform under normal operation, avoiding costly repairs or safety hazards. Several factors influence yield strength. The material's composition plays a big role. Adding certain elements called alloying elements can make metals stronger by blocking the movement of dislocations inside the crystal structure. Manufacturing processes like heat treatment or forging can also change microstructure and improve yield strength. Temperature matters too. Higher temperatures tend to lower yield strength, making materials easier to deform. In summary, yield strength is a vital property that indicates when a material will start to deform permanently. Measuring it helps engineers design safer, more durable products and structures. It's a fundamental part of understanding how materials behave under stress and why some materials fail while others endure.